Hi, I'm Rusty Lowe with the Globe Mission Mosquito Campaign. Today, we're talking about monitoring Earth system change using Globe Observer. You may already be aware of this, but Globe Observer is an Earth system change monitoring app. If we look at the four tools on the Globe Observer platform, clouds, mosquitoes, trees, and land cover, you'll see that these correspond to four main parts of the Earth system: land, water, air, and life. Here's the thing. If you regularly collect data using two or more tools on this platform, every time you make a Globe Observer observation, you'll be contributing to our understanding of changes in the Earth system. And why is this, you might ask? Well, it's because everything is connected to everything else. A change in one part of the Earth system will cause change to propagate in all directions. Let's take a look at the data that's available from Globe Observer using the Globe Viz system. To enter the Globe Viz system, we just simply have to click on the blue bar. And here is an easy-to-use interface that'll let you look at all the data that's available. Go to Data Counts, click on that, and you'll get all the data that's available for Globe Observer. Click on the protocol layer on the upper left. You'll see the spheres below. I'm going to choose hydrosphere, which is water, and I'm going to look at mosquito habitat mapper data. Let's see what we have. Anywhere there's a pink triangle, we have mosquito data. So Cassie and I would like to cordially invite anyone listening to this lightning talk today. If you're in a place where there's no pink triangles, we want data from you. And so reach out to us after NARM and we'll get you started using the Globe Mosquito Habitat Mapper. Okay, well, let's take a look at the other data that's available that we can see in the Globe Viz system. Here we see the mosquito data, the land cover data, and the tree height data all on one map. And what you'll see is we've got great coverage of trees, we've got some good coverage of land cover and mosquitoes, but we don't have them in the same place. What you have to remember about Globe Observer is that we are a new tool. In order to make robust scientific investigations, we don't have a lot of spatial data density and we don't have a lot of temporal density. But here's the thing. If you collect data using two or more tools, you can get around that limitation. This is what we did this summer with our Globe students. We had some NASA SEAS high school interns this summer, created 50 individual and team research projects. Out of those, 4 research papers have been submitted for peer review to the Columbia Junior Science Journal. And in addition, 2 peer-reviewed papers are in the works with student co-authors. So to summarize, this is possible. We can get really robust analyses using Globe Observer data if we go to the effort of collecting more than one data type using more than one Globe Observer tool. So now we are going to move to the second part of this lightning talk, and I'd like to introduce Brian Campbell, who will be talking about Globe Observer trees. Take it away, Brian.
Hi, this is Brian Campbell, lead for the Trees Around the Globe Student Research Campaign. Take a look at this picture, and what do you see? Do you see trees? Yes. Do you see land cover? Of course. Do you see mosquito habitats? Not necessarily, but that does not mean they're not there. Do you see clouds? Kind of tough. You do see a little blue from the sky poking through the trees, but not really evident in this picture. The purpose of this picture is to show you just how important it is to take multiple protocol observations using the NASA Globe Observer Citizen Science app. The reason why NASA Go is so important is that it's such an amazing tool to help us understand how the Earth functions as a system, how all of these observations come together to help us understand the Earth as a system, okay? Now, once you take those protocol observations, you're left with some data. Diving a little deeper into the data literacy that we're talking about here with the NARM, here's an example of comparing NASA Go ground-based data and spaceborne data. The map you're seeing on the left side is from a online tool called Open Altimetry. It's openaltimetry.org. And here you can visualize ICESat-2 data for the Ice Cloud and Land Elevation Satellite 2 height data from things like ice and land cover to oceans, to other bodies of water, to landforms. But we're focusing here on tree canopy height. So ICESat-2 hit a wooded area in my location. So I went out and I took observations of tree height and land cover using the NASA Globe Observer. Then I went and did some comparisons. I went on to Open Altimetry and looked up this location, and then I did some comparisons of the height measurements that I got from NASA Globe Observer and looked at the land cover, and then also what ISAT-2 got. And you can see on the right side, ISAT-2 and NASA Globe Observer, the data is very close. So the comparison turned out really well. And you can do this with lots of cool data. Okay, this is just something that's really neat to do. As the NESIC program, we want you to take multiple observations of these protocols when you're in one location. For instance, if you're out taking observations of clouds using the NASA Globe Observer, check around to see if you see any mosquito habitats and take observations. If there are any trees around, take observations. If there's any, the land cover is always there, so take a land cover observation, okay? All of these really help us understand this global picture of understanding how the Earth functions as a system. So don't also forget to come to our campaigns concurrent small group session if you want to learn more about the NESIC-led Globe campaigns, like Trees Around the Globe Student Research Campaign and Globe Mission Mosquito. This is happening on Wednesday, October 21st. This is day 3 of the NARM from 9 a.m. to 10 a.m. Mountain Time. Hope to see you there. Bye-bye.